Hi, in this video, I will take you through the work that I did for the project in class CS236. As you can see, the goal of the project is to investigate the challenges around building a generalized text-to-image generative model. Please have the project poster that I also submitted to hand, as I will be referring to sections from there. Thanks. I'll first give a brief summary of the project. Generative models that can synthesize images from text descriptions is a very exciting and challenging task in both computer vision and natural language processing. There are many practical applications. For example, we can imagine automatically illustrating textbooks for young children. In this project, we follow the three tasks or tiers of tasks that is recommended in the project description. The first tier is to do a one-to-one mapping between object class and word embedding. The second tier is to train on granular word embeddings and evaluate on coarse embedding. And finally, we train and evaluate on caption descriptions. We know from related works on GANs that they have very good results in synthesizing images. Therefore, we follow the same route going through each tier. It gets very challenging quickly, but shows promise. In terms of technical methods, we start off with two baselines. One is the pixel CNN++ method, and the second is the AC GAN method. For scoring metric for GANs, we use the inception score. And for experiments to improve on the baseline, we do a few. We start off with parameter sweeping, then we try increasing the depth of networks. We also try adding spectral normalization layers and self-attention layers. We also use a more complex CLS loss function. And finally, we add learnable embedding layers. Please see the poster for details on the network architecture. In terms of results, there were some clear takeaways. First, we know that GANs are notoriously difficult to train, and we found that. So parameter sweeping can make a large difference to the inception score. Adding spectral normalization layers also stabilized training. For the Tier 1 results, we improved from the baseline by adding more layers to the network, which implies that the baselines were underfitting. Also, adding self-attention layers to the system allows it to model dependencies across different regions of the image. And then for Tier 2, we found initially that the results were much worse than Tier 1 as expected. However, we found that we could improve the scores by adding a learnable embedding layer, and secondly, by using a more complex CLS loss function, which lets or enforces the discriminator to distinguish between real images and fake images, as well as images which are real but have the wrong text. To conclude, please see the poster for numerical results. In terms of qualitative results, we note that the baseline image quality was improved significantly. We also introduced some generalization on the Tier 2 task via richer embedding representations and a more complex loss function. And for further work before the final project write-up, we note that we only used 100 classes out of the possible 1,000 from ImageNet for Tier 2 task. This is to reduce the amount of computing resources. However, we can investigate the results on using more classes. Also, we need to continue work on Tier 3 task, which is training and evaluating on captions. There, we can introduce for example, an attention layer between the description and the region of the image which is being drawn at that time. Thanks very much.